So hi everyone, my name is Tran, and today for the video lab report, I'm gonna talk about the topic to analyzing the 3 Newton's laws of motion with real life examples. So the objectives of this report is to investigate the relationship between mass, force, and acceleration. Moreover, I would like to introduce the 3 laws statements and give example to have a better illustration to help views and draw an accurate free body diagram. And also in this report, I will explain the statement of the Newton's laws of motion to the readers, then help them be able to list out the examples happening to the real life, relate to the statements, and how to understand the laws applied to each example mentioned in this report. So moving on, at first I would like to talk about the definition of the first law of motion. It's sometimes referred to as the law of inertia. An object continues in a state of rest or uniform motion with a constant velocity, unless it is acted on by an unbalanced net or resultant force. So to explain more about the statement, I have a question for you that have you ever experienced the inertia? So inertia here, which means resisting change in your state of motion in a car while it is braking to a stop. So as you can see, the force of the road here, the force of the road on the log will provide the unbalanced force to change the car's state of motion, yet there is no unbalanced force to change your own state of motion. Thus, you continue in the motion, sliding along the seat in forward motion. A person in motion stays in motion with the same speed and in the same direction. So to prevent falling forward, we should wear a seat belt. So a seat belt here provide the unbalanced force that bring you from a state of motion to a state of rest. Perhaps you could speculate what would occur when no seat belt is used. They're gonna be damage your neck. So moving on, there will be another example, like have you ever certain experience that we have while traveling a bus can be explained based on the Newton first law of motion. So when we are on a bus, if the driver stop immediately, so we will be easily falling forward. So it's one of the application of the first law of motion. So that the reason we have to hold the hanger really tight to prevent falling forward when the car immediately stops. Or I have another really funny application, everyday application. So one of us one of us must use the ketchup at least once in our lifetime. So when we almost run out of the ketchup, to dislodge ketchup from the bottom of the ketchup bottle, we usually turn upside down and thirst downward at high speed and then abruptly halt it to get the ketchup out. Is one of the application of the first law as well. So moving on, talking to a different topic, I would like to introduce you to the simulation that we have done in class. So as you can see here, as the we have the I applied force at 229 newtons and change it by increasing the force to 500 newtons, then you can see the acceleration is also increasing. So we can say the correlation between the acceleration and force is directly proportional. And as we can see, compare the mass here and the acceleration. As the mass increasing, the acceleration decreasing. So the acceleration is inversely proportional to the mass. So we have the Newton's second law of motion, that is, if the resultant force act on a body, it will cause the body acceleration in the direction of the resultant force. So the acceleration of the body will be directly proportional to the resultant force and inversely proportional to the mass of the body. And the reason of that, the force of the total force, the total of the net force equal the mass multiplied the acceleration. So I have one of the example here. This the man pulling a box. So we have a man is pulling a 20 kilogram box here with a rope that make an angle of 60 degree with the horizontal direction. If he applies a force of magnitude 150 Newton and a frictional force of magnitude 50 Newton presents. So we will be able to draw a free body diagram, as the box is the object, it moving horizontally is the x-axis and is the y-axis. The force applied is 150, normal force, theta 60 degree, the friction and the gravity. And as we can see, the force we apply on the box is not belong to any x-axis or y-axis. So we later on we should decompose this vector to the x-axis and the y-axis. And one more thing I would like to emphasize, that the direction of the axis is following to the direction of the motion in this example, because the man is pulling the box moving to the right direction, so I chose the x-axis is going positively to the right, from the left to the right. So finally, I would like to talk more about the Newton's third law of motion. That is, if the body A exerts a force on body B, then body B exerts a force of equal magnitude on body A, but in the opposite direction. So if you hit a wall with your hands or legs while you're angry, you get hurt. So why is that? Because of the Newton's third law. When you hit the wall with a force, and that exact same amount of the force is returned by the wall. So please don't do it when you get angry. You will get hurt by yourself. Or while you're rowing boats, when you want to move forward on a boat, you paddle by pushing the water backwards, causing you to move forward. That is one of the application of the third law of Newton's. Yeah, we can see as we're rolling forward. As we're rolling backward, and the boats keep moving forward. So in summary, I would briefly talk about these three laws again. The first law is talk about the force at balance, then the object might be in two different situations. Firstly, the object might be at rest, which means the velocity is equal 0 meter per second, and the acceleration is equal 0 as well, and it stay at rest. In the other hand, the object is in motion, the velocity is not equal 0, but the acceleration is still equal 0 because it maintains the same speed and direction, so stay in the motion and keep moving in the same speed. For the Newton's second law, we should remember that the acceleration is directly proportional to the force and inversely proportional to the mass of the body, and the mathematical representation formula is the total force, the net force equal the mass multiplied the acceleration. For the Newton's third law, I would like to emphasize that if the body exerts a force on the body, if body A exerts a force on the body B, then the body B also exerts a force equal magnitude on body A, but just in a different position, opposite position. So these are three laws of Newton. So thank you for your watching.